My name is Tim Frazier, and this talk is on the aurora. I kind of feel obligated to explain the subtitle, which is Why I Took a Wrong Turn at the Airport. You see, every winter, my partner Pamela and I take a trip south to get away from winter weather. And so we usually go to places like Phoenix. But about a winter and a half ago, we took that wrong turn at the airport and went to Fairbanks, Alaska. And this was because I wanted to photograph the aurora. And Fairbanks is one place in the world where there's a very high percentage chance of seeing the aurora during the aurora season. Now, that season is from about early to mid fall to early to mid spring. Okay. Now, the thing about the aurora is that it has existed since Earth had a magnetic field, so that all of humankind that lived in an area where aurora was visible have literally grown up under it. Now, in doing some research for this talk, I thought, well, I wonder how old a depiction of the aurora I can find. And I was kind of surprised at how old that is. Okay, this is an image from a Cro-Magnon cave. It's about 32,000 years old, and it shows the aurora as these swirling patches across the sky. Now, the oldest written description of the aurora was about 5,000 years ago in China. Now, when you think about the aurora and you think about a culture that grew up under it, I think your mind immediately goes to the Vikings. Now, the thing about any early culture and something like the aurora is they attempt to explain it given what they have at hand. Now, we have science to help us understand these things, but what they had was a direct physical experience with the world and, of course, their mythologies. So in their mythology, they saw the aurora as the reflection off the shields of the Valkyrie as they carried the honored dead to Valhalla, or they saw the aurora as literally the Bifrost Bridge connecting Earth to Valhalla. Now, the Cree Indians in North America believe that the Northern Lights are spirits trying to communicate with loved ones still on Earth. And the people of some remote northern islands told tales that described the aurora as their walrus spirits, basically playing soccer with a human head. A particular poetic aurora myth stems from Finland, where the mythical firefox created the sky show by sprinting so fast through the snow that it caused sparks to fly up and ignite the sky. Northern fishermen saw the aurora as reflections of giant schools of fish and were omens of a good catch. Down under, the aurora australis, or the southern lights, filled Aboriginal astronomical traditions and is often associated with bad omens of death and plague, much like some Native American cultures. Now, the term aurora borealis was first used by Galileo. The term is derived from the Greek language where aurora means sunrise and boreas means winds. Now, by the time we get to the 16th century, the idea of the aurora was caused by candles above the celestial sphere illuminating areas that we saw as that optical display. But today we know what causes the aurora. And of course, it's our sun. Now, this particular image is one that I made of the recent total solar eclipse. And this is the instant where totality ends. And you still see the corona, that is the energized particles streaming away from the sun, and you see just a hint of the disk of the sun shining through. Now, as these particles stream toward Earth, they're bent around Earth by our magnetic field and channeled down toward our magnetic poles. These particles are moving at about 45 million miles an hour, about 772 million kilometers per hour. Earth's magnetic field then redirects the particles toward the north and south poles. Now, note the aurora oval there. That becomes important in just a moment. Now, when we look at the aurora, of course, we see these different colors. These next few slides are not mine. These are ones that I'm using with permission from the authors. The colors of the aurora indicate the strength, altitude, and which gas the solar wind is interacting with. Earth's atmosphere is approximately 78% nitrogen, 21% oxygen, and smatterings of argon, carbon dioxide, and other gases. Green is the most common color of the aurora. Green auroras are typically produced when charged particles collide with high concentrations of oxygen molecules in Earth's atmosphere at altitudes of around 60 to 190 miles. That is 100 to 300 kilometers. We also see green auroras better than any other color, as the human eye is most sensitive to the green color of the spectrum. Now, red auroras are less frequent and are associated with higher intense solar activity. They occur when solar particles react with oxygen at higher altitudes, generally around 180 to 250 miles, that is 300 to 400 kilometers. At this height, oxygen is less concentrated and is excited to a higher frequency, making reds visible. Red auroras are often seen at the upper edges of the green, as you can see in this image here, as the red is sitting on top of the green display. Now, blue and purple auroras are even less common and tend to appear during periods of extreme solar activity. These colors are produced when solar particles collide with nitrogen in Earth's atmosphere at an altitude of about 60 miles or 100 kilometers or less. Blue and purple auroras tend to be visible toward the lower parts of the display. Now, the most rare colors are yellow and pink, and are typically associated with the extreme solar activity. These colors result from a mixture of red auroras with green or blue. This particular image is the aurora australis, that is the southern lights, and this was shot from Tasmania. Now, in addition to seeing aurora from the ground level and looking up, it's possible to have a completely different perspective. This is an image of the aurora from the International Space Station. Okay, now, so we're looking down on the aurora, which is a very odd perspective. If you look at the top of the auroral display there along the rim of the Earth, you can see the red color, the faint red, just above the green. Now, aurora are also seen on other planets. This is the aurora on Jupiter. Now, this color blue is because of the wavelength this image was taken in. The size of this aurora oval would, well, you could fit a couple of Earths inside of it. Now, this particular aurora is on Saturn. I really like this particular image because it really gives you a sense of perspective that you don't normally get of Saturn. And here, of course, we see the rings and just the edge of the sun as it comes around the south pole of Saturn. Aurora are also visible on Uranus. Uranus is a very odd planet anyway. Sometime early on in its history, it got really hit very hard and knocked on its side. So its rotational axis almost faces the sun. It also rotates in the opposite direction on its axis from all the other planets in the solar system. Note that very thin ring of material around these images. And of course, we can see the white of the aurora. Now, when we decided to go to Fairbanks, here we are on a frozen pond. And there's, by the way, there's a reason for these kind of vacation shots that I'm going to get to in just a moment. But here we are near an ice fishing hut. Oh, our accommodations were excellent. And no, we didn't really sleep in this. We had a very nice place to stay in an area called Chena Hot Springs, which is about 60 miles outside of Fairbanks. We did participate in their winter sports. This is frozen miniature golf. They would lay out a course with some kind of batten boards, and they would pour water in, it would freeze, and that became the golf course. I also went ice fishing. The point of these slides is you can never replace local knowledge. When I mentioned to our ice fishing guide that I was going to photograph the aurora, he suddenly became very animated and began talking in very technical terms about the solar wind, about what parameters to pay attention to, and how to photograph the aurora. And his advice was quite useful. And he gave me two pieces that I particularly appreciated. One, well, of course, there's an app for predicting the aurora. And he recommended something called Amazing Aurora. Now, this is a graphic presentation of, or rather a chart presentation of the various parameters associated with the solar wind. But now notice the timeline. This will be in 5 minutes or 15 minutes or 30 minutes. So this is very up to date on what's going on. Now, instead of looking at all of these parameters and trying to deal with them, it also has this map of the aurora. Now, the color and intensity of the aurora oval shown there gives you an idea of how probable it is you're going to see that display. Well, this particular shape is called the ovation, which is a contraction of the word oval and other terms, including ions. Using this app, I chose a night to get on a snowcat and be driven way up into the hinterlands outside of Chena Hot Springs on a place where I could photograph the aurora. The snowcat, well, it was advertised as being kind of a cushy ride, something that had seats inside of it that were forward facing. And well, in the ads, they looked like they came out of the first class cabin of Qantas Airlines. The reality was much different. I'm sitting on a metal bench with several other people holding on for dear life as we smack and bang our way up to a place called Chena Dome, which was a hill that gave a great 360-degree view of the horizon. Now, when I arrived, I got out of the vehicle and looked up, and there it was. Just this faint flickering green and gray glow in the sky. Now, following the second piece of advice from our fishing guide, I set up my camera and used as short an exposure time as possible because, as he said, the aurora changes shape very rapidly. And boy, he was right. So I set up and made my first exposure. And I looked at the view screen and thought, well, what idiot left their red light on? Of course, unfortunately, that idiot was me. So, and I also noticed that this exposure really wasn't long enough to capture all the colors and detail that I wanted. So I increased it by a stop to about 15 seconds at f4 using an ISO of 6400. And then I began recording. Now, all of these colors, including that subtle pink that's down there by the horizon, were not visible to the naked eye. Now, there was a slight green cast, but all of these colors showed up in the photographs. The shapes and colors, and especially the intensity of display, changed very rapidly. Again, the advice of that guide to use as short a shutter speed as possible, well, it served me quite well. In a matter of minutes, everything shifted like some giant sky snake moving overhead. Features grew and disappeared minute to minute. You see how dark the image became. This was very sudden. And of course, it represented just the flux of the solar particles that was ongoing. Colors shifted as the charged particles encountered different gases at varying altitudes. It was easy to see how the native populations depicted the aurora as everything from benign to ominous. I mean, in this image, it literally looks like a snake in the sky. By the way, that sort of rosy pink on the horizon, that's also part of the aurora. Now, this is a time lapse of how quickly the aurora changed. Now, this was over a period of approximately 8 minutes. And you see in the middle of that where suddenly it gets dimmer. And it was just like that, like somebody had flipped a switch and the brightness just died. Again, the time lapse. Now, this is me standing under the aurora saying thanks for making the image. On that particular night, I made about 240 to 250 images of the aurora. This is over about a 2-hour time period. The temperature was about 5 below zero. My equipment performed extremely well, and I was dressed for the weather, so I was quite comfortable. Shortly after I made this particular image, the moon rose and the aurora disappeared. The next night, we left Chena Hot Springs and went back into Fairbanks. And we stayed at a hotel that had a very interesting wake-up service. They would wake you up and tell you, yes, the aurora is now visible. And so when I got that message, I went outside and photographed the aurora that night. And its shape was very different. Now, this particular display, it was easy to see how the Vikings believed that the aurora was literally a bridge, because this looks like a walkway in the sky. Now, the temperature was beginning to really fall. And the next night, we chose a location just outside of Fairbanks in what is a natural area that was a dairy farm. Now, in the summer, it's a marshy area and is a stopover for migrating waterfowl. But in the winter, they plow out an area where you can park, and I set up my tripod to photograph the aurora that night. It was about 15 to 17 below that night, and the temperature really became a factor in photographing. But the aurora displayed completely different shapes that night. And it was very fast moving. It was also much brighter. I could literally open up 4 stops and get these displays. They were literally changing moment to moment. They would look like this, then they would curl into a ring shape, then they would become curtains of color like this, or like this. Now, in this particular image, here in sort of just right of center, you can see the constellation Cassiopeia. So you can see where I'm pointing the camera. Some look like a spray of water. And, you know, it looked like it was raining down on you. Of course, you see the lights of Fairbanks there in the background. Now, this particular sequence shows exactly how quickly this auroral display occurred. What you're looking at here is an unprocessed image. So in other words, I haven't gone through and worked on it in Photoshop to bring out the colors that were there. This is more like the appearance to the naked eye. And note these changes, these sudden changes. All of this occurred within 1 minute. That's how rapidly they were changing. Now, once I processed these in Photoshop, I was getting images that looked like this. Now, again, I want to stress, I didn't add any color in Photoshop. I merely used the raw converter to bring out the colors that were there. And it's really important, if you're going to photograph anything like this, shoot in RAW. You need all the data you can get so you have more to work with. Now, whenever I finish a trip like this, I always do a post-mortem. That is, I look at what I did right and what I did wrong, okay? And in this case, there were some things that I did pretty well. First of all, okay, see if I can move this over or if I can stretch this a little. No, okay. Part of this is cropped off, but I think you can see the important things. The equipment, including camera, lens, batteries, accessories, and tripod, worked very well. Okay. They stood up under the cold, except toward the end of the night. It was about 15 below. At that point, the equipment was really beginning to freeze up. I kept spare batteries in my parka to keep them warm. And the night in Creamer's Field, I did need to change the batteries once. Okay. The exposures were long enough to capture sufficient detail and color density that I had plenty to work with. And my clothing, it was warm enough to work. At Chena Dome, when it was 5 below, I had no problems. In fact, I didn't even have to change the battery in the camera for over 2 hours of work. Now, at Creamer's Field, when it was 15 below, I knew it was going to be colder, so I put on thicker undergloves. So I had undergloves and overgloves. This turned out to be a mistake because when I peeled off my overgloves to hit the controls on the camera, my undergloves were too thick to hit some of the buttons, so I had to take them off, and I was touching the camera with my bare fingers. Then I immediately, of course, put my gloves back on, but still they were getting very cold. Okay, so I could have used another layer, and I should have worn thinner undergloves. Now, the bad. I had focus problems at Creamer's Field. When I took my gloves off to operate the camera, again, they were thick and bulky and my fingers weren't working real well. I bumped it out of focus. and I missed about 20 exposures. Once I noticed what was going on, of course, I corrected it and continued shooting. But this is a mistake I won't make again. Once I achieve infinity focus with that lens, I'll probably duct tape it down or something like that to be sure I don't make that mistake. Okay. The second problem, the second mistake I made was with the color balance. Every light source emits light that has a particular color temperature. This is measured in degrees Kelvin. And so our daylight exposures are at about 5,200 degrees Kelvin. Now, in doing my due diligence on the internet, I found a photographer whose aurora photographs were really particularly good. And so I listened carefully to what he said he was doing. And one of the things he recommended was changing the color balance from daylight, which is about 5,200 kelvins, to 3,500 degrees Kelvin. And that would be as if you're looking at a much warmer light. And so the camera corrects by making the image more blue. This proved to be somewhat of a problem because while doing that really brought out the greens and the blues, the cooler tones, it suppressed the reds. So when I opened the images, the raw images in Photoshop, in their raw converter, I had to go back and correct the color balance of each image. I'll show you what I mean. This is an image of a hill in winter near where I live in Bellevue. This is taken with daylight color balance. Now, if I shot this at 3,500 degrees Kelvin, the camera is expecting much warmer light, so it biases the image to the blue. And this is what you get. And you see how off these colors are. This was what I had to correct in the raw converter in Photoshop. However, when I did this, I did get, I think, some images that I'm very pleased with. This one in Creamer's Field is particularly good. And you can see down here some of the deep blues and some of the faint reds here above this display. And this one from China Dome, where you can see again these subtle colors up here above the display and these wonderful pinks and violets that indicate it was a very active solar night. Okay. Now, ladies and gentlemen, I do plan to go back and try to photograph the aurora again. In fact, in checking that amazing aurora just before I made this recording, I discovered that tonight, that's Friday, the 10th of May, that tonight there's a high possibility of seeing the aurora here in Idaho. So I plan to go out and try to photograph it then. I guarantee you I won't make the same mistakes with the exposures and color balance. I'll probably go on and make new ones, but I'll correct those eventually. Well, thank you. I know this is not exactly the presentation that I had hoped to give, but I hope you do enjoy it. Thank you very much.